Okay, so we learned about how pointers can be combined with the arithmetic expressions, and we also learned how what is nothing but a scale factor. Right? I hope you all are clear with that concept. We'll move to the next thing. The next thing is how pointers can be combined with the functions. We already learned how what is nothing but a function. Okay, a group of statements which can be combined and can be given a name called a function name. And whenever you want to execute that block of statements, simply we can call that one by using your function name, right? So that function, to that function, we can pass your pointers as the arguments. I hope you all are reminding that concept, which is called as call by value and call by reference, parameter passing techniques. We learned call by value and call by reference. Do you remember that one, all of you? We observe the difference there, and I already told you we will be learning in detail at the time of learning this pointers concept and all. So let us learn that one today, right? So normally, whenever you are passing any arguments to the function, that arguments can be simply a value, or that argument can be your address also. These things we learned at the time of learning that parameter passing techniques. Now, what is the difference we have learned there is at the time of passing the address as an argument to a function, we need to store that address in a pointer variable. That is what we have done by storing that address in a pointer variable, and that's why we declared that one as star p. Do you remember that one or not? We'll see once again that example. Okay, so that passing the address is called as is named as call by reference or call by location. Okay, pass by reference can also be called. So where we are passing the address. The other way is where we can pass normally the values directly. Simply the data values will be copied from the calling function to the called function. Okay, so what is the difference we have observed at the time of learning the parameter passing techniques is we could observe like if you are passing only the values, then there are no changes that are reflected in our actual arguments. But if you are passing the address, any changes that you do in the formal argument that will reflect your actual argument that we learned by learning the swapping of two values. Let us revise that one once again. So first one, you can see passing the values by the value. Simply what I have done here, this AB values I have taken. A value is 5 and B value is 20. We are passing A value and B value to this function called swap. Then what happens? The A value will be copied into X and B value will be copied into Y. Now in this case, what happens? I'm revising once again. We have already learned these things. In this case, what happens? A value, we are creating A, and A value will be 5. And then we are creating a B, and in the B we will be storing the value of 20. Now what happens whenever you are calling a swap function, again two more variables are created. What are the two variables? X and Y. And in the X, what happens? A value will be copied as it is. Nothing will be done. So what is A value? That is 5, which will be copied to X. And what is Y? B value will be copied into Y, that is 20. Now what happens? Here we are taking a new variable again, which is T. Okay. And in T we are storing X. What is X? 5. So T will be storing 5. And X will be storing Y. That means this will be removed and Y value will be stored at the X. Okay. And then Y value will be stored with the T. So this will be erased and T value will be 5. So we have done swapping of X and Y values. So after executing this function, the control will go back here. It will come here. It is trying to print A value and B value. What is there in A? A is 5 and B is 20. So simply by passing the values as argument, it will copy the values. But if you are doing any changes in X and Y, it is not reflecting your actual arguments. Isn't it or not? So this is called your pass by arguments, and we can observe here, even though we are swapping X and Y, it is not swapping A and B values. You can see here, it has swapped the X and Y, but it is not swapping the A and B values. So the output what you will get, A equal to 5 and B equal to 20. Understood? But if you pass your address, So what do you mean by reference? Reference is nothing but your address. So whenever you are passing the address, observe here, instead of passing A only, we are passing ampersand A. So ampersand A is nothing but address. So if you are passing the address, always the address should be stored in a pointer variable. That's why we wrote here star x. This is the reason why we are writing this one as star x. If you write normal x is nothing but it can hold only a value. But if you want to store the address of A, then we can store that one in a pointer variable only. So again, let us see. A is storing 5, okay, and B is storing, what is the value? 20. And let us consider the address of A is 100 and address of B is 102. This address can be any address, okay? And it has created a new variable called px, and x is a pointer variable which can hold only the address. So that address is address of A. What is the address of A? Which is 100. So this is the 100. And we have created one more variable y, and it is holding the address of B. Ampersand B is nothing but address. What is that address? 1 of 2. 102 will be stored in y. Now one more variable is created t. Observe here, t is a normal variable which is not a pointer variable. Then what is t? T will be holding star x. Can you tell me what do you mean by star x? Any one of you, what do you mean by star x? What do you mean by star x? Yes, star x is nothing but value at x. What is x? X is 100. Value at 100 is 5. So t will be holding that value which is 5. Very good. Star x is nothing but value at 100. So what is value at 100? It is 5. Okay. Now coming to here, star x equal to star y. What do you mean by star x? Value at 100. Value at 100. This I want to replace with value at 102. What is value at 102? 20. So this will be replaced with 20. Understood all of you? Now what is the next line? Value at 102. Value at 102. That means this one. I want to replace this one with t. What is there in t? 5. Now what happens? It has swapped the values of star x star y. That means 101 and 102 values has been swapped, which internally is changing the values of, exchanging the values of A and B. Got it? So with this we can say, like, if you are passing the address, any changes in your this value will obviously reflect your actual arguments also. So we will be getting the value of A value as 20 and B value as 5, which is nothing but swapping has been done, which is not done in our earlier case of passing simply a value. Got it? So this is how pointers can be combined with our functions also. Right, all of you? So you can simply understand here, you can pass the address, but if you're passing the address, that should be your pointer variable. This is how pointers can be combined with your address. Now, if you see scanf statement, I'm revising once again scanf statement. Normally for printf statement, we'll be writing x, y, x plus y, because whatever value you have in x, that will be copied here, and whatever y you have, that will be copied here, and whatever operation is done, that will be copied in the third position. But if you are reading any value, we need to use the scanf function, and in the scanf function, we want to read a value and you want to store that one in our new location, in an address. So to do that task, we should not write like this, because it is nothing but we want to allocate memory to this x. But if you write normal x, it is nothing but we are storing the value and we are not allocating any address for that one. That's why this is a wrong thing. We need to use like this, where in the scanf we are using ampersand x. What do you mean by ampersand x? We are trying to allocate some memory to this x, and in that x, whatever value you give, that will be stored. If you write like this, this is wrong. We have normally used this one. Number of times we have used this one in our programming. But the reason behind that one of putting ampersand, because we are allocating an address to this variable x. That is the reason behind putting ampersand in scanf statement. This is the right one. Got it? That's why I'm revising the scanf statement. unknowingly we have used these two statements, but the reason behind putting ampersand x is, that is the reason, because we want to allocate some memory. Got it, all of you? So this is how a pointers concept can be connected with your functions concept. I hope you all are clear with this concept.